Hey everyone, welcome back to the channel. If you're new here, please hit that like and subscribe button so you don't miss any of our weekly uploads. And with that, let's get into it. So today we'll be covering Amazon GuardDuty. This tool is often confused to be a SIEM. Is actually a threat detection tool within AWS. We're going to cover the differences between that and the SIEM, and then what this tool offers from a security perspective and what it can do to enhance your baseline in AWS. Okay, so what is Amazon GuardDuty? GuardDuty is a continuous monitoring threat detection tool that uses a combination of machine learning and threat intelligence on the back end to help detect anomalous behavior in your AWS environments. So what that means is you have AWS accounts within an organization, and you have CloudTrail logs and VPC flow logs. GuardDuty monitors those things by default to detect behavior that is outside of the baseline in your environment. What that means is GuardDuty actually takes some time to adjust it when you enable it. It actually watches and listens to your CloudTrail logs and listens to your VPC flow logs to see, hey, what does normal traffic in this environment look like before it starts throwing out those anomalous behavior alerts. And then of course there are some signature-based alerts that are built in on the back end that allow it to detect pretty specific and called out alerts that the world is pretty aware of, so CVE related alerts. So why would GuardDuty be important for your security baseline in AWS? I would say for most businesses, this automatic threat detection across all of your AWS accounts will give you that visibility that most tools out of the box are not going to give you. AWS does have some partnerships aligned with companies like Splunk and IBM with QRadar and even Wiz. These other organizations are fantastic, don't get me wrong. It's just that when you're using GuardDuty, you're using the native tools to their cloud. So you're gonna have that access, that seamless access to their APIs on the back end, and be able to view CloudTrail logs easily and fluidly, as well as VPC flow logs, along with a few other sources that I'm gonna cover in the next slide. Yeah, as I alluded to in the last slide, VPC flow logs, CloudTrail logs are like the default logs that are enabled. DNS logs or Route 53 for AWS are also something that are enabled. And then some options that are available to you would be enabling EKS and RDS logging and monitoring, as well as Lambda monitoring. And then the big one is Malware Protection snapshot analysis. And that's where that agentless piece of GuardDuty comes into play, because since it's analyzing snapshots, it's not actually interrupting any of your services, and therefore the agents don't need to run on the back end of your EC2 instances, your Kubernetes clusters, or your containers in ECS. So I mentioned earlier that Amazon GuardDuty is enabled in all of your AWS accounts for your organization. Unfortunately, that is not the default behavior. It has to be configured that way. And you do that by basically enabling like an organizational mode, or when you build a landing zone in AWS Control Tower, you can configure a delegated administrator. You put that either in a security account or a security tooling account or something like that. And then you auto enable all new accounts by default, and then you tell it which features do you want to turn on. So like in that last slide, we talked about EKS and RDS log monitoring and Lambda monitoring and malware, snapshot analysis, all that stuff. Those are options that can be enabled as well, but not the default option. The default option is just that VPC, CloudTrail, and Route 53 logs, which does get you a ton. Don't get me wrong. I mean, that is all of your CloudTrail logs is essentially all of your API access or API activity that takes place in your AWS environment, and then VPC flow logs are all of your network traffic that takes place in your AWS environment. So definitely not skimming out by going with the default. but those extra features like give you a little bit more visibility and a little bit more peace of mind of what's going on in your AWS environment. So I noted earlier that GuardDuty by itself is not a SIEM, and that is true. It is a threat detection tool, anomalous detection at that, and that's great. But with some of the other integrations that it has, you can start to treat it like it is a SIEM. Tools like Security Hub, which is a tool I will demo at a different time. Lambda and EventBridge allows for that auto remediation action to take place, and then you can write step functions for actual workflows, and then those SIEM tools that I mentioned before. All of those things kind of can be integrated together with this tool to make it a SIEM or function like a SIEM. But by default, GuardDuty does not do any remediation on its own. All right, so a few shortcomings for GuardDuty. It is a great tool. I think it works extremely well in AWS, but I will have to call out that, again, like it's not a SIEM. It does not block network traffic. As a matter of fact, it doesn't block anything by default unless you enable some Lambda, CloudWatch, EventBridge combination to block something or to do something, some action outside of notification. It does not do any endpoint protection, and it does not do any retroactive log analysis. So if you enable GuardDuty 3 months after your environment was enabled, going forward, you will have visibility and protection, but it will not have any compatibility going backwards. It will not do historical searches in CloudTrail. So if you are kind of enabling GuardDuty later, or we're on the fence about enabling it, and you want to take a look at your CloudTrail logs, it might be a good idea to dump those old CloudTrail logs to like an S3 bucket and then do some historical analysis on that, maybe using a tool like Cribble to pipe those logs to another SIEM tool or another threat detection tool that you can then do analysis that way. All right, so if I haven't lulled you to sleep yet and you're still with me, I appreciate you. We're going to go ahead now and do a live demo of GuardDuty in the AWS console. I'm going to show you guys how to enable it at the org level, how to set up automatic enablement in all of your accounts, how to toggle those features, so what features are enabled automatically when new accounts are spun up. We'll do some finding analysis on some dummy data that I've generated, and then we're going to walk through a example of how to automate remediation action in GuardDuty. So with that, let's go ahead and jump straight into that live demo. All right, so we're in the GuardDuty dashboard right now. Right now, you're looking at the summary page, and here you're going to see your total findings and the resources that have findings associated with them, and the accounts with findings in them. Right now, because this is simulated data that was only generated in this account, you're only seeing one account with findings and 16 resources with findings. These are all random, and the findings are all fake. So keep that in mind. If you enable this in your accounts and we do it the way that I'm talking about in this video, you're going to have significantly more findings, more accounts to look at potentially, and then of course significantly more resources. So keep that in mind going forward. So the first thing we're going to look at is how to enable GuardDuty at the org level. And in the dashboard, this is really simple. Obviously, AWS best practice, and what I would recommend would be to enable all these actions with infrastructure as code. So Terraform, CloudFormation, stack sets, CDK, however you wish to do that in a pipeline. But I'm just going to walk through doing it in the console today. For ease of use, and also so we can all see what's going on. So let's look at settings here. So to configure AWS GuardDuty, the first thing you have to set up is your delegated administrator. You're not going to want this in your management account for your AWS organization, because that account tends to be your root user, which if you secure that correctly, you're not using root API keys anymore. You're not using the root access anymore in that account. So you want to set up an admin privilege for a delegated administrator and that's usually like a security or security tooling account that you would set that up in. So in the console, you would just drop in the account ID you wanted to enable and hit enable, and it automatically, based off your organization, will populate your organizational ID. And now you're ready to manage guard duty. So now you'll have control over all the accounts and what features are enabled by default. So we went over all the features and things like that in the slideshow and the presentation. So I'm not gonna kind of rehash those things again, but I will cover here that you can see they're all listed here. And if they're not enabled by default, just like if guard duty is not enabled by default, you can come up here, you hit edit for managing auto enable. And so right now I have it set to do not auto enable because I wanted to show you guys this here. This is your foundational data sources. We talked about that being CloudTrail, VPC, Route 53. So you say enable for all accounts. So that means by default, GuardDuty will be turned on in all of your accounts. So you'll have some type of threat detection in every single account by default. Um, and then these are all the additional or optional protection plans that you can add on. All of these have their own costs associated with them, and some of them are more manual, like these malware protection for EC2. You can configure schedules for these to run. Um, but ultimately they don't run by themselves unless you're doing like a like I said, like a planned run. Otherwise it's going to ask you to do ad hoc scans for EC2 instances, and then the rest of these tools for the most part run on their own by default, and then do that anomalous behavior for you, that anomalous behavioral detection for you. Um, and that's pretty much it for how you set those up. And then it's really in the console anyway. It's easy as just clicking enable, do not enable, depending on what you want to do. I would say a good example would be if you're running all of your Lambda functions in one account, because you want to centralize where all your serverless actions are taking place, and then you just run cross-account roles or cross-account execution roles from that central Lambda account or workload account. You wouldn't want to turn this on in every account. You just want to turn on Lambda network activity monitoring in that one single account. Um, just an example, but that's definitely something I've seen before, and would make sense if you're trying to, again, centralize how your organization operates in the cloud. So we're going to save those changes. We got, as you can see now, we have auto enable for new and existing accounts set up, and we've already had it turned on here. So I got ahead of you a little bit and cheated. So hope you can forgive me for that. All right, let's go back up into summary. We kind of went through the features, we went through enabling and settings and all that stuff. So let's go ahead and jump straight into some of the finding analysis. So we're just going to pick the first one right here on top. Uh, you see here that it's going to give you a pretty in-depth explanation. It's going to call out that MITRE attack framework, tactics that were observed, and how it came to its conclusions. Uh, and then this right here is something I like to call out when I say, okay, you want to really see how it was coming up with that this was an alert, and that's something that you need to take a look at. And it's showing right now that this user, this particular IAM user, so it was John Doe, was basically manipulating objects in an S3 bucket, and manipulated a few things like deleting cloud trails and attaching policy for IAM, which is typically what we see when someone's trying to escalate privileges and they want to try to clean up what they did. And then they got S3 list objects, list bucket, then they put block public access block back on the S3 bucket. They got object, deleted object. Like, so basically what this means is they were probably doing some type of data exfiltration, and they enhanced their own privileges to do some of these things and then tried to clean up their footprint. So um, these types of things can be gleaned from the alerts, but obviously you can do some more digging. And then you see here to the right, now it's got like a whole story of what it saw and what actions were taken and what order they were taken in. So this type of information can be super helpful in an analyst trying to understand what alert took place, why it took place, why we're seeing this alert. So you're not stuck doing too much guesswork as to say, okay, was this a false positive or true? Is this a true something that a false positive, or is this a true positive, or are we just not seeing alerts at all, which would be disturbing. But for the most part, in guard duty, if you're not seeing an alert, more than likely there's nothing to see. If you're not seeing an alert, that means that it's not seeing any anomalous behavior in CloudTrail or anything in VPC or Route 53 that would be raising any eyebrows. So, and then it's also showing the resources that were affected. Remember, these are all fake. So the bucket names all say examples, but this would obviously be listed with the true bucket names, the type, and then the ARN associated with that bucket. So then you can go into those resources and do some more digging just to see associated with the timestamps that we saw in in the storyline and the signals. We can go back and say, okay, these are the timestamps. Let's go ahead and do our own investigation into these. And then now you might want to go take a closer look at this user here. Like, is this a existing employee, or has this employee been here for a long time, or did this employee just, magically appear, you know, 9 hours ago, and now we got, serious problems. Uh, so all those things to keep in mind and consider when reviewing logs and guard duty. Um, but for those that are in incident response and have done log analysis, having this view kind of broken out to you already, letting you know what patterns we're seeing and all those things, that's pretty awesome to have out of the box without having to do any follow-on investigations, etc. And honestly, if you're looking at this and you're like, you know what, this is probably bad news, you then go check out these resources like we talked about. Write up your incident report, do your incident response um, chain of custody process if that's something that has to be done in this situation, and then follow through on cleaning up the incident itself. So. All right, and with that, we're going to go look at how you would set up a auto remediation action using GuardDuty. Oh, and before I move on to the auto remediation actions with GuardDuty, I also wanted to show you some of the other views from the dashboard. Just some cool visualizations, pie charts and a severity chart and all those things, and then of course resources with the most findings. This will let you know what account it is, and then what types of resources you're having issues with. And then, of course, you could, click on these finding counts and then drill down into each of those findings the way we just did when we looked at that finding above. Um, and then what occurred the least, which is not necessarily a good thing. I mean, one-offs are usually the ones that could be the most dangerous or the most damaging. So this is also a good view to look at as well. Say, hey, I'm seeing, these types of findings, one or two of them, and maybe these actually pop to the top of your list of things. Hey, maybe I should check that out. If you're only seeing it once or twice, meaning that, hey, it could be a false positive, which is best case scenario, or B, you got some serious issues to go check out. And so just keep that in mind. And then now we will go ahead and jump into the auto remediation piece. All right, now we're going to go straight into the auto remediation action using Amazon EventBridge or CloudWatch EventBridge, depending on how long you've been using the cloud. And then we're going to tie that in with Lambda function and even show you how you can do that stuff with some step functions. So I like this view here because now we can kind of drag and drop, and I can kind of show you and visualize exactly how an auto remediation action could take place, and then what you can do with that. So we're going to go over here to services. It's got our guard duty one right on top as the most popular one. So we're going to drop that in as a triggering event. So say that IAM alert that we saw earlier. was in there, which as you can see here, once I drop GuardDuty in there, it's going to ask me, you know, keys and principal ID. It's going to ask me for, strings to match, container details, EBS, ECS. So it gives you a plethora of things to say, okay, I want to match, alert that has these types of things in it. In GuardDuty, so we're going to match GuardDuty, a finding there, and then we're going to go ahead and make a Lambda function as a target. And with that, if you're making a Lambda function as a target, let's go ahead and make SNS a target too. So in short, now that I've done this, if I was to actually go in here and fill this out, so setting up the SNS topic, setting up the Lambda execution role, and then maybe setting up a dead letter queue, just in case there was some failures when trying to process the Lambda. Um, you basically would have your finding trigger this Lambda function, and the reason why you want to have an SNS topic triggered off of this finding too, because if you're going to do an auto remediation action, you probably want to notify, whether it's the security team or your SOC lead or uh, however your organization is run, you want to notify the responsible parties before you go ahead and do something. A good example would be like that IAM user we referenced earlier in the video. Say we want to block that user's keys or remove that user's keys so that way they cannot do any more damage or any more exfiltration. We could set this Lambda function up to do that automatically, and then again send this SNS topic out, so an email out to the organization or the team that's responsible for incident response to say, hey, this was already done on your behalf. We've removed this guy's keys, and now you can go ahead and continue your investigation. So basically, you're kind of moving straight into your incident response phase with this and saying, okay, we want to, disable keys and stop this person being able to do any more damage than what's already been done, and then we can go ahead and assess what's been done or hasn't been done to this point. So that's really it as far as like what we're going to show in this demo. I could go into detail and try to do this whole vibe coding thing. I actually figured that might bore you all to death. Um, but if that's something you all would be interested in, just leave a comment in the and let me know if that's something you'd be interested in. Some vibe coding sessions and actually going through and making some Lambda functions and sending data or sending information in an SNS topic. And maybe we can make that happen.
And that's it for today. If you have any questions, please leave a comment below and I'll get back to you as soon as possible. And I may even make a video addressing it depending on the scope. If you'd like to set up a formal consultation, please visit my website in the description, and at the bottom of the page, fill in the form so I can schedule a formal Zoom call with you so we can bring your security posture to the next level in AWS. And with that, have a good rest of your day. And remember, security starts with base.